Hey everybody! In this video we'll talk about using the rational zeros theorem to find all zeros of the polynomial. Now, so we're given a function and we're told it has at least one rational zero. Now if you need some more help with rational zeros and the rational zero theorem, you can go back to a previous video that I've done. But we're told this has at least one rational zero. So that means that it has some zero of the form p divided by q. So that means factors of 15 over factors of 2, which is going to end up getting that if there's a rational zero, it has to be of this form. It has to be one of these. Plus or minus 1, plus or minus 3, plus or minus 5, plus or minus 15, plus or minus 1/2, plus or minus 3/2, plus or minus 5/2, plus or minus 15/2. That's a lot of possible options, right? Now, we're told one of them is a 0. One of these is going to be a 0. So what we can do is we can just start checking some of these possible zeros to see if they are zeros. So let's just try one. Let's do some synthetic division. So 2, -5, -28, and 15. That's going to give us 2, bring down the 2. 2 times 1 is 2. We're adding these. -5 plus 2 is -3. That's going to give a -3 here. -28 plus -3 is -31. -31 times 1 is -31. And then we add those, we get 16. That is not 0. So that means 1 was not a 0. Okay, so let's try -1. 2, -5, -28, 15. So this can sometimes feel tedious, right? Because I have to potentially check that many zeros before I find one. Right here we're going to end up getting 36, not a 0. So -1 is not a 0. One thing you can do, and this is just a little hint, is you can actually get on your calculator and you can graph this function. Okay? And you can maybe see about where it's crossing the x-axis and maybe try that value as a 0. Okay? So let's bring down the 2 here. 2 times -3 is -6. -5 plus -6 is -11. We'll get 33 here. -28 plus 33 is 5. We get -15. Oh yes, finally, we get a 0. And what does that tell me? That tells me that x minus -3 is a factor of this function, right? Okay. But that also tells me that f of x equals x minus -3 or x plus 3 times my quotient that I got from that division. 2x squared minus 11x plus 5. Okay, so What do I do from here? Well, let's see if this factors. 2 times 5 is 10. What adds to be 10, or adds to be negative 11, but sums to be 10? Negative 10. Sorry, adds to be negative 11, multiplies to be 10, and negative 1. Okay. And then after we do some factoring, we're going to end up getting x minus 5 times 2x minus 1. And this is our function. Okay, so we factored this piece down to those two pieces. Now we find our zeros by setting the function equal to 0. Right, and then each piece equal to 0. And once we do that, we'll end up getting our zeros are wherever x equals negative 3, 5, and 1/2. And those are the zeros of that function. So we found all zeros of the function because it's a cubed function. So I know I can have at most 3 zeros. I also want you to notice that our answers were all of the form P over Q. That is the rational zeros theorem.